Today I'm going to talk a little bit about using the libav libraries that are part of the Ffmpeg suite. I really try to condense this down from a larger talk, so it might not flow perfectly, but let's see how this goes. Basically, what I've noticed a lot in my career is a lot of people use Ffmpeg as part of a bigger system. This was about 30 seconds of GitHub searching of people who just call system process launch Ffmpeg, a whole string of commands to try to get the video job done that they're trying to get done. I'm not saying there's anything wrong with this. If you do this, that's great. There's absolutely nothing wrong with that at all. However, Ffmpeg is, of course, wrapper is not the right word, but it is the interface on top of the libav libraries. This isn't the same thing as the libav project. I'm not going to get into that. But the libav libraries, which that project was probably named after, is really the workhorse underneath Ffmpeg. So it involves quite a few libraries here. There's the libav format, which does the file parsing that'll read and write MP4s, MKV. That happens to do a lot of the codecs as well, or I'm sorry, a lot of the protocols as well. There's libav codec, which does the encoding and decoding. That might do it internally. Ffmpeg ships with a lot of its own codecs, or it might outsource it to something like X264. There's the filters, there's the devices for interfacing with, like your deck link and stuff like that is in the device. Libav util is just something that's shared across. There's software, resamplers and rescalers. There's all these libraries that Ffmpeg uses to get the job done. This is a quick video of just the bottom of the Ffmpeg option.c library of all of the options that you can pass in on the command line. And this is just the initial options. This doesn't include filters. This doesn't include some more of the advanced stuff. This is just the absolute basic list of things that you can pass in on the Ffmpeg command line, which just goes to show you how powerful this is behind the scenes, that all these things have to be converted into commands to drive those libraries. So the Ffmpeg executable is really responsible for taking those options, parsing them, and then just running the main loop. And that main loop goes through the input, basically frame by frame or packet by packet, calls all the necessary functions below in those libraries in order to get the end result that you ask for. Again, it's an amazing tool, but personally what I find is that those libraries are actually way more powerful than what Ffmpeg can actually expose, because it can do so much and because command line can only be expressed so much. So from that, I really believe that there is an opportunity for a lot of people to build their own custom tooling on top of these libraries. Not saying that needs to be done for everything, it's just an option for when you need it. So a common way of doing that, of course, obviously, is to take Ffmpeg, patch in what you want to patch in. The big problem with that is, of course, if you're doing something that's very useful for the whole community and you have the time and effort, you should really be committing those patches back. That's not always practical. Sometimes you can't change the package back because you changed the default, and you can't set that back to the community because they expect the defaults to remain the same. So now you need to add new flags or switches to the command, which makes your work larger in order to get done just what you need to get done. The time and maintenance, once it's into the package, you're kind of responsible for it. You have to keep it up to date, which, again, if it's something that's great for the community, I highly recommend we take advantage of that. But your patch might not apply to others. Like, you might have something that only is necessary for your company or your individual use case. So applying it would actually not be good. It might be secret sauce. You can't submit it because it's proprietary, patented maybe. Or your company just might have a shitty open source policy, in which case Mux is hiring as well. So because of this, what I see a lot of people go is to a custom fork route. So they take Ffmpeg, git clone and start tweaking. The biggest problem I see with that comes in the upgrade. So now you have your custom patch, and now you do a git pull or a git merge, and everything just blows up. Tons of merge conflicts happen in this case. You oftentimes in this case start using unstable APIs. Now the code doesn't even compile, even if once you resolve the merge conflicts, which means you're inevitably running an old version of Ffmpeg. This leads to many security problems. There are security patches all the time in this system. So because of that, you're running an old version of Ffmpeg, you're susceptible to these security flaws. So basically what I'm saying here is you can use these libraries to build your own tooling when applicable. Up here is a few links to some tutorials on how to do that. I'm going to actually walk through some code here next. I just wanted to point these out because these are way more complete than what I'm going to go through. The Ffmpeg examples are great, but they're not well documented, so you'll see a lot of function calls, and they're there, and you know you need to call them, you don't know why. The next tutorial I just found today, it seems to be pretty good, and then of course there's I don't know how you say it, it's Dranger or Dr. Anger, I don't know what it is, but that's been around forever. It's a great tutorial, but it's continually going out of date, just because Ffmpeg keeps changing. So if you go and download tutorial 1 right now, it won't compile because Ffmpeg has changed since that last tutorial was updated. So I'm going to go through some code, and this is basically the workflow I'm going to go through. I originally planned on doing an encoding example, but I wanted part of the subtext I'm trying to give here is that this isn't incredibly difficult. And going through an encoding example kind of worked against me in that case. So, instead of doing an encoding example, it's actually easier to write a quick GUI app and actually just display the frames on the screen. But what I'm going to go through here is the basic workflow of a basic decoding of a file in Ffmpeg. The process is basically here, we're going to open the file, analyze it, we're going to configure the decoders, we're going to send the read frames from the file, send those to the decoders, read the results back from the decoder. I'm going to display those in this app. At the end, we have to drain the decoders and then clean up the whole library. So I just wrote this utility using the Qt library for the GUI. Not necessary, it's just what I was able to put together quickly. Everything that I'm using from the libav tools, I wrapped in this libav include header, which I'll try to open source after this, or I will open source. The only reason why I haven't yet is it's not in a great state, but I'll clean that up and open it up. Well, let me start by doing this. I'm just going to show you the app to show you how it works. It's just a quick GUI app, open file. I made this little clip file. It plays. I don't have it reading timestamps, so the frame rate's wrong. So I created this decoder thread just to keep the GUI responsive. Normally, you don't have to create your own thread here. Since it's a GUI app, I had to have a responsive app. And this play function is basically the entire set of instructions I said before, where I said we're going to open the file, which is that line on line 47, configure the decoders. We do on line 48. We read the packets from the file in this for loop. We send the packet to the decoder in the send packet, and then the decoder automatically returns the frame here. This is just to keep the thread responsive. And then, of course, we drain at the end. Obviously, for those of you who know libav, this is not standard libav code. I've abstracted this away to make it look way easier. But this is basically the core loop. So I'm going to set a breakpoint there. I did, and launch the debug. I promise I'm not going to spend an hour going through code. That's why I got rid of the encoding example. So I will open my clip, and I hit my first breakpoint. So to dig into the Ffmpeg, I'm sorry, I keep saying Ffmpeg, I really mean libav code a lot. That is just converting the string. And here we are into the open input. So what I did in this library is I took a lot of the Ffmpeg concepts and abstracted them away slightly. So if you notice that function before, I didn't have any cleanup code. There's actually a lot of cleanup code. But I made it automatic with this abstraction, and I can show that there. In order to keep things consistent, I try to name things in this familiar, similar way. So the AV format context, normally you have one from libav format, which is designated here by the 2 colons. That means you're using the one out of the root namespace, or the global namespace. So stepping through here, basically anything preceded by the 2 colons is the ffmpeg command. Anything outside is my code that calls it. I'm sorry, libav command. So, so here we have the AV open input. So this basically just opens the input file. You pass in the URL and a pointer to a context. And this is so libav can clean itself up later and clean up the pointer and null it out later, so to make it a little bit safer. In our case, we're not going to use that feature, but it's good they did that. So first we open the file by passing in the URL, and the result is it populates this format context. We get an error back out, and in this case it's 0, which you can't really see in the upper right there because I can't make that text larger, but you'll see it's 0, so it succeeded. Next, we did the find stream info. So this actually opened the file and read some of it. It looked for what are the tracks, what are the codecs, what is this file, what's the format, and it tried to read just as much as the file as it needed to continue on. Sometimes that's a little, sometimes that's a lot. This is sometimes called the analyze or probe duration of during an ffmpeg command line. In this case, again, it succeeded, returned nothing, or 0 as an error. And then here is where I talk about the cleanup. So I take that pointer I get back, and using a C++11 unique pointer, I immediately attach the deleter. So this means later on, when this goes out of scope, it automatically calls the correct close input function, and I don't have to worry about leaking resources. It's just all automatic from this point on. So that is, now I've opened the file, I've analyzed it, I found all the tracks. Next, I need to configure the decoders. So I'm going to step into that. I'm going to step over this first. So I'm going to try to open a video and an audio track. Now the clip I used only has video just to make the example easier, but I'm going to try to open both. So I'm going to try to open this video track using this little open function I created here as a lambda. This is going to use the libav command to find the best stream. So this basically tries to find the primary video stream. In the case of like MP4 or transport streams, you might have multiple streams in the same file. This will try to find the best one, what it deems as best. Once it's found the best streams, that returns a pointer to the codec object of what the codec that stream is using. We're now going to configure a decoder. So on this line 160, we're going to create a decoder using the allocate context. This just sets up the decoder in memory. It doesn't do any initialization. The next line, 161, takes the codec parameters from the stream we just opened and copies those parameters into the context we just created. So basically, we created a decoder, and now we're setting up the decoder to decode this specific track by copying its parameters over. Once those parameters are copied over, we then call open, 2 in this case, that says, okay, now actually initialize the codec. Go run all the code you need. The structure is set up. Let's go ahead and open up the codec to do our decoding. And then finally, the same thing I did before. We take the pointer that we just created, wrap it into a unique pointer, so it cleans itself up automatically at the end. I'm also going to return an index, which I skipped up here at line 156, which is the index of the video stream we just read. In this case, it's going to be 0 since there's only one track. And then it returns all of that. We're going to try to do the same thing with audio. As I said, this file has no audio, so it's going to fail immediately. But the one difference this one did is it actually passed in the video index. So if you do have multiple audio-video streams, this way it'll pick the correct audio for the video that we've already selected. But this will just return null. I'm sorry, is this text large enough? Can everyone see well enough? Okay, good. So now I need to keep this codec parameter, so I'm just going to stick it into this map I made. We'll come back to that later. The audio failed, so it's going to skip over that. So now we're ready to decode. This part is a modern C++ feature, which personally I find very convenient. But if I step into this code, what you'll see is that I actually ended up calling this function begin. In C++ 11 and beyond, anything that has a begin and an end function that returns something that can be incremented, you can use in a for loop. So in this case, it's taking this begin function is creating an AV packet and passing in the get is the way of getting the pointer to the unique pointer. So it's passing in the video context that we created earlier. So that creates this AV packet. Again, we create a packet at the beginning by calling AV packet alloc, and then setting up the deleter so the packet cleans itself up at the end. Next, we were supposed to read the frame, but my breakpoint wasn't there, so it skipped over it. But we'll be reading many frames, so I'll come back to that in a second. And our function pulls the first frame out. Now, this frame is still encoded. This is the raw encoded frame. So now we can send it to the decoder using this AV send packet. So in the AV send packet, again, this is a wrapper I built that takes the context. It takes the packet that we're getting out of the for loop, and it takes a function that we will call when we get a frame. So we find that codec context that I created earlier in the map. We found it, so we continue. We send the packet to the decoder. We create a new frame to store the result in, and then we say, give me the frame, and then we error. So the reason why we error is because ffmpeg, or I'm sorry, libav codec, behind the scenes spawned a new thread to do this decode. So when we gave it the packet, it stuck it into a new thread, and of course returned immediately in order to keep the application going. And this is why later on we have to drain. So I'll step through there. It skipped the frame callback. We come back to our loop, which skips the lambda. Again, that's just to keep it, the thread thing is just to keep the GUI responsive. So we go through the for loop again. This time I'm going to step through the read frame. I accidentally skipped this the first time. But we'll use this read frame with the format context that was passed in at the beginning, and the get, which returns the pointer to this packet. We got a frame. So here is interesting. I was going to spend time on this, but I'm actually going to skip it. I'm converting to a standard time base, so all of the frames operate on the same time base. Normally, every single track might have its own time base, so comparing timestamps gets very complicated. Here, I'm using the Flix timescale that Oculus developed, which is very cool. I was going to talk about it, but I would probably spend 30 minutes talking about that, and I know you're starting to get bored already, so I'm going to skip that. So we now have the packet, and we come through, we return, and we still don't have enough video for the decoder. So I'm going to set a breakpoint there and just hit run. I'm going to get rid of that breakpoint. And eventually, we're going to hit this emit frame. This emit frame function uses the SW scale library to convert the AV frame object to an image format that my GUI library wants to use. So you'll notice I'm actually on line 22 and 23 here. I'm actually not changing the size. I'm converting from width height to the same width height, but I am changing the pixel format from whatever it is to RGB 24. And then the conversion happens on line 28 here, where it actually populates the pointers of the image, and then this emit on frame sends that frame to the display. So now the video is starting to render back here, except because I'm in debug mode, things are very slow back there. So that loop just continues until we reach the end of the video. I'm going to skip back out of here. One more. And get to the drain of the function. Set that breakpoint. So, oops, let me remove that breakpoint. So if I hit that and move back, we should see the video playing now, because I removed all the breakpoints, so it's just looping as fast as it can. And then it hit that new breakpoint. So it reached the last frame in that loop, or I'm sorry, it reached the last frame in the file, but there's still frames cached in the video decoder. So we have to drain those, and that's easy enough. We just use the very same send packet function, except we create a null packet with a pointer to null pointer and a size of 0. So I create that dummy packet. I send it to the same send packet function that I was calling before here. And then that should go through this loop and drain the rest of the packets. So that should flush it out, although the frame looks very similar because that was a still scene. We get to the end, we exit, and as soon as I hit that button, all of those destructors, or all those deleters that I wrote at the unique pointers, just ran when we hit that last line. So when we hit that line, all the libav libraries all cleaned themselves up right at that instant and reached the end of the file. So that's the basic functionality to go through. The great part about this, of course, is not that workflow, but here you have your opportunity to inject your code. So if you need to manipulate the raw packet before it goes to the decoder, you have it right here. So you'd have packet.data. So there's a pointer to the raw packet. If you want to manipulate the raw video file or the post decoder, we have those pixels right here. I just did a quick mem set here. So for example, if I want to, this just takes the plane 1 and 2. I'm going to stop this code. So I just added those 2 lines. It just sets the number 128 to the second and third plane. Run it. Open my file. And of course it's black and white because I nulled out or cleared out those 2 color planes. So and of course it popped in color at the end because I did not put the code there. So this becomes very powerful because now you have access to all the data in the stream. You have the raw data of the video, you have the raw data of the decoded video, you have all of the timestamps, you have every bit of detail in the entire video, and you have an opportunity to change it or manipulate it as the process is going through. And in the grand scheme of things, using an abstraction like this, let me write this program in 10, 12 lines of code using that abstraction library, of course. So obviously this gets much bigger. There is the filter graph, which I was going to cover, but I've already gone way too long. So this will let you set up a rotate. So this filter graph, all the code is there, but this will rotate the video by 12 degrees. And play, because I'm calling emit frame and not filter frame. Where's my filter frame function there? There, now the video is playing 12 degrees tilted. So you can build the whole filter graph with just little strings like that. I actually created the code to turn this syntax into a full filter graph. That's in the component I'm going to open source. Again, I'm not sure if I made my point, which is, if you use these libraries, there's so much potential that opens up, and you can build new tools that Ffmpeg might not let you do on the command line, while simultaneously making it easy to pull in new libraries. So if you were to update Ffmpeg behind the scenes, it'll probably just compile because that API is very stable. And if it did change over the course of years, you might have to change 1 or 2 functions here or there, and you won't have the merge conflicts, you won't have the problems of committing back, you won't have all that. So that's, I don't really have a finish, but that's pretty much what I wanted to show you guys tonight. Is there a C API? Yes. So libav actually is a C API. I originally started writing this using the C API. So this is actually an example of the C API. And this does something very similar to what I did, except it just writes the files to a PPM to disk. I originally was going to show something like this, but I felt that demonstrating the ease of use was actually a little bit better. I thought the wrapper proved my point a little bit more about being able to simplify things, especially around cleaning up. So you'll notice this little filter this little tiny function has 1, 2, 3, 4, 5, 6, 7 cleanup lines in order to make sure you get it right. So if you miss any of these, you're going to be leaking memory. So those are the things that I really feel make using libav hard. So by abstracting it, by using modern C++, by using ranged for loops, by using unique pointers, I really feel it simplifies it. So yes, there is a C API. That is the default API. What I showed here was a small abstraction on top of that. So everything I showed here is all done on CPU. So any GPU decoding, which is a little bit of a misnomer in a lot of cases, because normally a GPU quote-unquote decoder is typically a hardware decoder that's part of the GPU silicon, but it's not actually typically the normal like CUDA cores, for example. There's usually a little piece of silicon to the side specifically for accelerating video encoding and decoding. Everything I showed here is software driven. You can use hardware with Ffmpeg. Earlier when I showed when you opened the codec, I just used the codec returned by the find best stream. But you can find a specific implementation of a codec at that point and pass in a specific implementation to open a specific decoder at that point. So if you had a hardware decoder or encoder, that's the point you would do it at. Here where I'm calling find best stream and I get a pointer to this AV codec object, that is a specific implementation of a codec. So there's actually a find codec function, and then you can say like, give me the quick sync, or give me the NVEnc decoder at that point, and then configure that with open. In my experience, modifying the Ffmpeg library becomes problematic not at the moment, but down the line. So I've seen that done in a number of cases, but usually what I've seen happen at that point is then the people tend to, or the organizations tend to get stuck on that version of Ffmpeg forever, because they might go pull the latest Ffmpeg or libav, and then they'll have conflicts, and they'll try to fix the conflicts, and then they'll run the code, and then it crashes. Now I have to go debug that. That, in my experience, is what happens in those scenarios. Then they tend to just stick on that version for a very long time. And then maybe once every 2 to 3 years, you pull in another version of Ffmpeg.
Why is that not going to happen?
I'm sorry?
Why is that not going to happen?
So what happened, the reason why this is a little bit different from that perspective is the high-level API changes a lot less often. And when it does, the documentation tends to keep up with it. So if I was to, I mentioned that showed this file, if I was to compile this, as I said, it won't actually compile. I must actually already fix this one to make it compile. But what you'll notice a lot of these warnings where it's saying it's deprecated. These deprecation lines were actually there because the function was specifically marked deprecated in the header file. And if you go and look at that function, it'll say use this function instead, or something along those lines. So if you do pull it and the high-level API does change, there's a guide to help you get to that updated API. Whereas if you changed in the ffmpeg.c file and you do a merge and you have this giant conflict, there's no guide there to help you. You got to figure it out. You have to go in and figure out all the things they changed and how to reapply your changes to that. I'm not saying that happens to everyone. I'm just saying in my experience that's happened a lot.
But if I type make, I'm not going to argue with you much
Sure.
longer. But if you type make, you're going to get these same warnings.
No, not
building up.
warnings, errors. Merge conflicts are errors, and then in this case they may have deprecated an API, but it'll still work for a while, and then they'll lead you to a new one. So like this line here about the codec being deprecated, that was replaced with the codec parameters field, for example. But it still works, and it's still here, and I have a path. I have a path to get to the new version. This isn't a codec doesn't exist error. And then you say, what happened to codec? I have a path forward using the high-level API. Cool?